So how would changing the amount of water or maybe changing the temperature affect the solubility of a salt? So what do you guys think about that? Let me give that some thought. So let's say you had a beaker of a saturated solution of silver fluoride and you were to add more water to the beaker. What do you think would happen to the solubility of that salt? Would it go up or would it go down? Well, you might think that if you add more water, I guess you could sort of think, well, what would happen to the amount of solute in the beaker? And so if, let's say we added the water right to the highest level here. So I think most of us agree if you added more water to a saturated solution, you would decrease the concentration of the ions in solution. So right now, let's say the molar solubility was 2.0 times 10 to the minus 6. Well, that means the concentration of the silver ions would have to equal the concentration of the fluoride ions. And since 2.0 times 10 to the minus 6 moles per liter can dissolve in water to form a saturated solution, then the concentration of each of those ions would be 2.0 times 10 to the minus 6 molar. Now the definition of concentration, at least in molarity, would be the number of moles per liter. So you're not really changing the number of moles initially, I guess, but if you were to add more liquid, the volume would go up, which would lower the concentration of the ions. And if you think about the equilibrium reaction for this, that would cause the reaction to shift if you were to decrease the concentration of these ions. So of course, if you decrease the concentration of the silver and fluoride ions, there should be a shift towards ion formation. So I think most of us would probably agree that the amount of precipitate at the bottom would get smaller, and you would have more ions in solution. Now, what can be sort of misunderstood about this is that might lead you to conclude that the solubility of the compound increased then because more of it dissolved. But what would happen is the number of moles of silver and fluoride would increase in the solution, but you also have a bigger volume of solution. And so since the molar solubility is 2.0 times 10 to the minus 6, that would be the maximum number of moles possible in the solution. So the concentration of the silver ions and the fluoride ions would still be equal to each other in this case, and they would still be equal to 2.0 times 10 to the minus 6 molar. So by adding more water, you don't actually change the molar solubility of the salt. You do decrease the amount of solute at the bottom of the beaker, but if the solution is still saturated, then it would have the maximum number of ions possible in solution. And of course, if you were to, say, boil some water out, you just have the reverse effect, which would be going this way. So let's say you heated the solution, drove off some water, you'd have a lower amount of water, and what would happen then is the concentration of the ions would exceed the saturation point, and so you get more precipitate forming. So really adding more water, removing water, it actually has no effect on the solubility of a salt. But let's say you took this beaker, this saturated solution, I'll just draw it out again, and let's stick with our precipitate being the silver fluoride. So just draw a little layer down here. And let's say that you were to take the temperature and you increased it, you caused the temperature to go up. Now you would have to know something about the reaction. We've seen from early on that the effect of raising temperature for most solutes tends to favor the dissociation into ions. And so where do you think the heat term would be in this reaction if that was true? So that is, if you were to raise the temperature and the reaction caused a sort of a higher degree of dissociation. Well, since the reaction is going this way, when you raise the temperature, you're making more ions. That means the heat term would be on this side. Now, that's actually not true for every salt out there. There's a few exceptions to that. We did go over that in class before the break. I believe it's calcium acetate actually shows the opposite effect of that. So in this situation, let's just say this was the reaction. And you decided to raise the temperature. Would that actually change the solubility of this salt. So once again, raising the temperature causes temperature to increase. That's going to cause the reaction to shift. To make more ions. And so what that would cause actually is more ions to enter solution than would normally have entered solution. So in this case, you would have actually caused an increase in the solubility of the salt. And of course, if we did the reverse, if we took the temperature and let's say we lowered the temperature, made it really cold, that's a really big fat letters. I think my daughter was using this to draw a picture. So if we take the temperature and let's say we lower the temperature, then the reaction would shift. To make more solid. And that would actually cause less of the salt to be dissociated or dissolved in the water. So this would cause a decrease in the solubility of the salt. You might remember from chapter 2 that we did spend a fair bit of time talking about how the raising and lowering of temperature shifts in equilibrium. And so by doing that, we actually change the molar solubility of a salt by either raising or lowering temperature, which is also why the KSP values on your data sheet, it does say at 25 degrees Celsius, these are the values that we use. And so if you raise or lower the temperature, those values wouldn't be valid anymore. So we generally assume that most chemical reactions in a question are at 25 degrees Celsius, unless there's maybe some other information given that might make you sort of go, that doesn't seem right in this case. But generally it's a safe bet to say that it's at 25 degrees Celsius. And then once again, all those values on the KSP table would be valid to use any kind of calculation you might have to do. But by changing the solubility of the salt, you affect the molar solubility. And of course, if you change the molar solubility, so if molar solubility goes up, so if molar solubility increases, that would cause the KSP to also increase because you'd have more ions in solution. And if the molar solubility was to decrease, so in the above example, if we lowered the temperature, the molar solubility would have gone down, so there would be fewer ions in solution, and that would cause the KSP of that salt to decrease overall. And so just to show that maybe for this reaction, the KSP would be the concentration of the silver ions and the fluoride ions. And of course, if you cause them to go up or down, that's going to change the KSP of the reaction. So just to summarize, changing the amount of water, so adding more water, removing some water from a saturated solution, although it does cause the amount of solute to change maybe in the beaker, it doesn't actually change the molar solubility. That is the maximum number of moles per liter that can dissolve at that temperature. But changing the temperature of the solution will cause a change of the amount of ions in solution, which will change the molar solubility. You would probably need to know whether the reaction is endothermic or exothermic, but you can see from the above reaction, just going back to that, with the heat term on the left here, that reaction actually is an endothermic reaction, at least for the dissociation. The crystallization reaction would actually be exothermic. So depending on the reaction, it could change. But I think a safe bet is if you raise temperature, you can dissolve more solute for most salts. So I hope that helps sort of the last little bit on increasing and decreasing the solubility of the salt. And from the previous videos, you can see other ways to do that too.